Here's section 7.5, example 4. And here they have a spherical tank. So here's the spherical tank. It has oil in it, down here somewhere. And they want to know, let's see, so a spherical tank of radius 8 feet, so I know that's 8, and is half full of oil, or it's half empty, one of the two, depending on whether you're an optimist or a pessimist, I guess. So it's half full of oil that weighs 50 pounds per cubic foot. So 50 pounds per cubic foot. And find the work required to pump the oil out through a hole in the top of the tank. Okay. So out through a hole in the top of the tank. And the way we can do this is, so I'm going to kind of redraw things a bit. So here's where we're starting with our oil. And, we need to pump it up to here. And so here's 8 feet to start with. And so now to pump this little layer of oil here up 8 feet, what I can do is take a little delta H and take that area, so pi r squared, and I know that's 8 feet. So this is a lot like a disk method sort of thing. My volume is pi times 8 squared times that delta H. So that's how many cubic feet of oil I'm going to pump up 8 feet is that. Okay, and then I will multiply that by the 8 feet. Okay, now here's something that's a little bit different. Oh, wait, and now that's the volume, but I also have to, so there's volume, and I shouldn't have put the 8 times 8 feet there on volume anyway. But now, so our force is that 50 times the volume. So that's 50 times 8 squared times pi times delta H. And then now we'll get the work, which is F times 8. Okay, so here's a case where F actually is incorporating the delta X or delta H or delta whatever, and the distance is this 8 feet. And so we have at this point 50 times that 8 squared pi times delta H, and then times 8. So there is our first delta H. And we will, but, say I'm down here somewhere. So I've come down this far. And now it becomes a matter of what do I want to call these different values. Okay. So I can, where's my axis system? And I'll try to do it much like they do. So they seem to put their axis system through the middle of the sphere and out this way. And so here's X, here's Y or H. And so as I do this, I need to make sure I kind of, keep in mind what we're working with here. So so now I need to figure out what I do here. So what I know is I'm going to cut this up into small layers of oil because a small layer will give me a small volume. That volume I can multiply by 50 to get my force, and then I can pump that up however far I need to go up. Well, how far is that? Well, okay, so let's work on kind of how we did it here, our volume first. So if I'm here at this value, so I start here at 0 and I go up to 16. The textbook switches from H's, well, I don't know if they ever used H's, but they use Y's. And so if I'm, here as I go, right, I can just think how much did it, how much work was it to pump that layer out? How much work was it to pump that layer out? And so at a given value of Y, along the way, so, as I look at this, I know I'm going from 0 to 8. Okay, but then how, so how far did I have to pump it and what was the force? Okay, so let's look at our volume first. How did I get that volume to begin with? I took pi r squared. Oh, okay. So I need the radius here at any given value of Y. Okay, well, okay. So this is a case where I would prefer, I think, personally, I might put the axis right in the middle and use negative numbers and that sort of thing. But I don't know. We'll see. They don't. So they say, okay, what is this curve out here to get this radius? Well, it's a circle. Okay, it's a circle with center 0, 8. So a circle with center 0, 8 is x squared plus y minus 8 squared is equal to, and the radius is 8, so that's 8 squared or 64. So that's my curve. And so that means, and I need my radius squared, so that's nice. There is x squared is 64 minus y minus 8 squared. I don't know if it's worth writing this out. It probably is, because if I square that, I get 64 minus y squared, and then a plus, because a minus and a minus, 16y, and then a minus 64 here. So that is just 16y minus y squared. So that's kind of nice. So that's my radius squared is 16y minus y squared. So I took pi, my radius squared, so that was 16y minus y squared, and my delta h or delta y, and so I'll put that out here. And then the only thing I need is how far did I pump it? Well, for a given y value, I pumped it all the way up here to 16, and so that is 16 minus y. Okay, so I have that much, and and I keep forgetting my 50, so I also had that 50 here to change the volume to the force. Okay, so I put all that together. That's what I have. And this is just a power rule if I multiply everything out. So this is equal to 50 pi, integral from 0 to 8. 16 times 16 is 256y. Then I have a 16y times a minus y, that's minus 16y squared. Here's another minus 16y squared. And so that is minus 32y squared. And then plus y cubed dy. So this is 50 pi. Now I'm ready to do my antiderivative. I get 256y squared over 2 minus 32y cubed over 3 and plus y to the 4th over 4. And that's from 0 to 8. So the 0 doesn't matter. And so I plug in that 8, and that is 50 pi times 256 over 2 is 128. So I get 128 times 64 minus 32 times, well, 64 times 8 is 512 times 512 over 3, and then plus, well, I have here 8 to the 4th, but I can make that 8 cubed, and then 8 over 4 is 2. So this is 1024. So I have that much. So this isn't, terrible. I just, I can't divide 3 into this thing, so I get, something involving 3, and I look at what they have, and they say, well, this is about 50 pi times 11,264 over 3, and then if we check that with a calculator, they say it's about 589,782 foot-pounds. I'll believe them. Okay? So I'm good to hear, and then I'm just believing them from there on out. But so, this is an interesting one, partly because our force, which was based on the volume, actually was the thing that had the delta X or delta Y or delta H in it. That's the first of any of the examples where that's happened. Usually the delta, that small piece, comes from the movement along that piece, right? So times, our force times delta X. But in this case, the force incorporated that delta H, and then we had some other items for the length that we had to move something. So there's example 4.